What if anything you could dream, you could automate? What if autonomy wasn't just the province of experts, but anyone, in a matter of minutes, could build their own custom autonomous system? It's time we democratize AI for the rest of us. Today, PassiveLogic is bringing generative autonomy to the world, focusing first on buildings, and we're just getting started. Buildings stand as the single largest robotics challenge in the world. The average building exceeds the system complexity of anything else humans make by orders of magnitude. And with buildings and industrial systems responsible for 68% of the world's energy consumption, and 40% of that energy wasted due to bad system control, it's an imperative. That's the equivalent of nearly 4 gigatons of CO2 per year. That's more than the energy consumption of the whole transportation sector combined. The impact of implementing truly autonomous control within the built environment isn't just the equivalent of converting all gas cars to electric. It's like getting rid of all cars. In fact, buildings are the single largest carbon reduction opportunity in the energy economy. Over the last decade, climate change has gone from data and predictive models to very tangible environmental and economic impacts that are unfolding every day. These big challenges require big solutions. It's time we reinvented our future. PassiveLogic has built that future. Today, we're sharing with the world what we've been creating here at our headquarters in the heart of Silicon Slopes. We've brought together the world's leading experts in AI, digital twins, compilers, and autonomous systems. And together, we've built what is truly one of the most ambitious projects in the tech industry. A few years ago, I met Jeremy, PassiveLogic's now CTO, as he was building a super cool house designed for sustainability. As the founding engineer behind Fusion.io, he was researching building automation solutions, and he asked me, where's all the modern stuff, things that belong in the 2000s? At the time, I was working on the foundational technology for generative autonomy, and together, we decided to revolutionize this market.
Our teams have been working on this technology for the last several years. It's been a fun and rewarding experience, and we're ready to share that with all of you.
How are the rest of the technical teams doing? Are you guys ready to pull back the curtain?
Yeah.
Let's do this.
Alec, are you ready?
Just 1 second.
Today, generative autonomy starts here. Today, the PassiveLogic team is thrilled to unveil a game-changing ecosystem of technologies and products. And building all of this for you has been an absolute blast for the team and, of course, a lot of hard work. Today's event is more than just a milestone for PassiveLogic. It's a significant leap forward for the entire industry. Today is about platforms, it's about common digital twin languages and connected workflows. It's about establishing new technology foundations for AI that sets us up for the next decades to come. But fundamentally, today is about one really big idea. We at PassiveLogic believe that you should have incredible products that are fun to use and that democratize autonomous systems for everybody. And these products should make your work go faster and more efficiently, but cost the same as what you're paying for today for old-fashioned control systems. And perhaps most importantly, we believe that energy efficiency, climate impact, and ESG are a right and come for free. We don't monetize our future on this planet. It's important to note before we get started, we didn't build all this in isolation. It's been a partnership from the beginning with you, our customers. So first, the PassiveLogic team thanks you for all your shared excitement and your investment and your feedback. And most of all, presenting us with the problems that sparked PassiveLogic's journey from the very beginning. Solving your very real problems is what today is all about. The built environment stands as the single largest robotics challenge in the world. While autonomous vehicles may have dozens of sensors, they only have 3 major control points: steering, braking, and acceleration. Industrial robots have 6 axes of freedom and a similar number of sensor points. Yet the largest buildings in the world are trending towards 1 million I/O, sensors and controllables, or in robotics terms, degrees of freedom. And even the smallest of buildings have hundreds. And that complexity makes buildings not only the most complex systems humans make by orders of magnitude, but also makes them what we call in computer science an intractable problem. Which means while theoretically solvable, you're never going to be able to solve it through brute force methods like manual programming, sequences, and hand commissioning. In fact, if you work out the math for the average building, it would take the typical programmer over 1 million years to solve the dynamics for every scenario. That reality leads to all the artifacts we experience every day in buildings, from the pains of installation to poor comfort management to the world's largest accounting of wasted energy. With the newest BMS platform out there pushing 25 years old, we're bringing the equivalent of an iPhone 15 to a flip phone fight. Because incumbents emerged out of the Industrial Revolution with the breakthrough technology of the mercury switch thermostat, over 100 years later, a building automation platform, or BMS, is really nothing much more than the digital emulation of that same thermostat, plus some timers and an algorithm called PID, which was invented in 1922. And on the smaller scale, like residential homes, smart thermostats and fixed function controllers are no smarter than their predecessors. They are like that digital mercury switch with their own website. It's no wonder we can't make anything work well. And integrating more and more point solutions to band-aid this situation only makes it more complicated, not simpler. And yet, every year, buildings are getting more complex. We're being asked to manage and automate a growing suite of domains. With advances in IoT and smart sensors, renewables and energy storage, grid interactivity and demand trading, occupancy systems and integral business operations, logistics and industrial systems, and a growing suite of new types of equipment like heat pumps, whose whole mandate of high efficiency is subject to actually being controlled correctly. What's missing from this whole picture is the brain for buildings. Without that, these technologies are just an island with limited potential. And that brain needs to manage all of these systems and more. In fact, buildings are what we'd call a systems of systems problem. It's not like driving one autonomous vehicle. It's like autonomously managing a whole fleet of systems in coordination. What's so much more important than the optimization is the automation control universe that lives between those individual systems. That in-between universe is a much bigger unexplored world than the individual controlled systems themselves. And because the incumbent control platforms were designed to compartmentalize this complexity into dumb control loops to make it even manageable, they will never be able to address the big questions in automation. We need a new way. We need autonomous buildings to control the dynamics and the complexity that we see on the ground, to adapt in real time to events, to make systems achieve their efficiency potential, to bring emergent insights to life, to tell us intelligently about the upcoming faults before they occur, and to manage our assets and give us the operational tools to transform our businesses. And to address the diversity of the world's buildings, we need autonomous systems that can deal with all of the combinations to give you control over your design and your own future. That means generative autonomy. So today, to make this possible, we are introducing 4 major breakthroughs. A breakthrough platform for generative autonomy, a revolutionary ecosystem of digital twin applications, the first digital twin language for composable AI, and fourth, the world's fastest AI language and tool chain. Today, I'm going to walk you through each of these breakthroughs, discuss some of the major challenges the industry is currently struggling with, and then take you on a deep dive through each of these products to bring these technologies to life. And as you explore your future in generative autonomy, we think you'll agree we are just beginning to understand what is possible. And we are excited to see how you'll use this game-changing platform. So let's back up for a minute and ask, what is autonomy? And more specifically, generative autonomy. It's important as an industry, we have a taxonomy. And it turns out the automotive industry did it for us with levels of autonomy. Everything that is true about the car industry is the same in buildings and industrial. The incumbent platforms on the market are level 0 autonomy, manual control. You set your car's cruise control to 60 miles an hour and you go 60 miles an hour. In a building, you set the thermostat to 72 degrees and you go 72 degrees. In fact, cars and buildings use the exact same algorithm called PID. And in both scenarios, the systems are running at a rate, but have no idea where they're going, why, or how. The goals are lost to the system. The car doesn't know about its destination, and the building doesn't know anything about your comfort, since air temperature is only about 20% of the information needed to describe comfort, let alone the systems it can use to achieve that best comfort. In level 1 autonomy, cruise control uses ultrasonic sensors to measure the distance to the next car, to automatically slow down and then speed back up once that car in front of you has moved out of the way. Today, this technology is the edge of the building market. The same dumb control systems with machine learning, model predictive control, or often just regular engineers in a remote office tuning the parameters of those existing controllers. But what should be really obvious is that we will never build full autonomy out of cruise control. What we at PassiveLogic focus on is full level 5 autonomous buildings. In vehicles, this means that a car navigates from point A to point B on a two-dimensional map, driving wholly by itself, picking the optimal path, and following the rules of the road, stopping for traffic lights, and adjusting for emergent situations like pedestrians. In buildings, it's much the same, only buildings don't move in space, they move in time. So the PassiveLogic platform navigates from point A to point B in time, but in buildings, we aren't just navigating one vehicle, we're navigating this whole fleet of subsystems, all in coordination, which isn't a 2D problem, but a multi-dimensional problem. One, at the end of the day, that resolves to a similar autonomous solution. It's like looking down a tunnel of time and seeing millions or billions or trillions of potential paths between now and the future, with all of the on-ramps and off-ramps and forking, major highways, small country roads of control space, and then selecting the most optimal series of decisions across the next second, 5 minutes, 6 hours, or even the next several days. But what sets buildings and industrial systems apart is that they are all different. Autonomous cars can be made by the millions, copy-paste. But the built environment is a world of one-offs. Every building has a different architecture, systems, equipment, topologies, and business processes. We don't need single-purpose autonomy. We need general-purpose autonomy, where anyone can design, generate, and deploy their own custom autonomous system for any application in just a matter of minutes. Today, we'll introduce you to the Hive Autonomous Platform that makes all of this possible. And it comes with a bigger framework for autonomy, where autonomous vehicles focus on just control aspects of autonomy. Generative autonomy is concerned with much more, like autonomous assessment of our environment, controls values, self-training, automatic sensor fusion, and in-the-field learning. Perhaps more important than the autonomous systems themselves is what they enable and how they will change the way we interact with the built environment. Because every single person who interacts with a building, and that's all of us, needs individualized solutions. We want digital transformation and the freedom to work our way. We need digital twin connected workflows, so this isn't just about automation integrators and contractors. If you're an architect, you want your design intent to be preserved throughout the build and come to life in occupancy. You want to enable unique ideas and not have them value engineered out because they are impossible. If you're an engineer, you want the promise of simulation, performance-based sizing, and the ability to prove that high-performance designs are actually going to work, but with even less effort than your current sizing spreadsheets, not more. And since you are stamping the plans, you want less risk, like guarantees that automation is getting installed the way you intended. If you're a management firm or owner-operator, today you have close to zero insight on your portfolio. Buildings are effectively black boxes, run by manual labor that's aging out. You want buildings to be intelligent and manage themselves, solve problems, and give you deep analysis. You want them to let you know when to send maintenance crews ahead of time before a crisis. And of course, you want real ESG benchmarking, not just feel-good hand-waving. You want energy and operational savings, but you don't necessarily have the budget to invest in tools beyond the required control systems. If you are an occupant, you want buildings to be working for you, not asking more of your time and spamming you with notifications. That's not smart. We want buildings to understand comfort, not just air temperature, and adapt to where we are and what we're doing. If you are a manufacturer, you want your control systems to understand equipment and how it works and how to automate it efficiently, so contractors can easily integrate your solutions. And even more importantly, you want data back from the field to make your products work better in the future. Finally, if you're a technology provider, you want an API for buildings so that customers can add your services without the huge integration costs that are holding back today's PropTech market. Today, we'll introduce PassiveLogic's ecosystem of digital twin applications that cover all of these use cases and more. And even more exciting, we are providing real-time collaboration to all of these applications, not just on an application-by-application basis, but in a first in any industry. Collaboration works across the whole ecosystem from end to end. Now, digital transformation is no longer a buzzword. We're making it reality. And to achieve generative autonomy, digital twin collaboration, and many of the technologies you see today, you need a language for autonomy, one that can describe the meaning of things, how they work and what they do, and how to control them. What you need is digital twins. Today, we'll introduce Quantum, the first computable open standard for autonomous systems and the built environment. This breakthrough is perhaps the most important for laying the foundation for the future. It enables a new form of composable AI called deep physics that powers the whole PassiveLogic stack. And finally, to make all of these innovations possible, we need new AI frameworks and languages for industrial systems programming and edge applications. We need AI to grow up beyond hobby languages and research tools. To power the next wave of applications beyond yet another chatbot and image recognizer, we need AI tooling to merge with real systems programming languages so we can get it into the hands of the computer engineers that architect our real-world applications. If we're ever going to scale beyond gee-whiz research and data science, we need AI tooling integrated into compilers that, together with systems programming, can provide the modern constructs that we need for building durable applications like concurrency, memory safety, type checking, and real compiler support. And finally, the real revolution in deep learning wasn't neural nets. Those have been around for decades. It is differentiable programming that powers the training behind those networks. And today, that feature is trapped behind the narrow lens of tensor frameworks and scripting languages. We need differentiable computing integrated right into the languages we program our systems and applications with so that we can power the next ideas in AI. So today we're introducing Differentiable Swift, a language extension that started at Google Brain and continues development here at PassiveLogic. And boy, have we invested a lot in this feature. PassiveLogic currently has built a larger differentiable compiler team than most of the big guys put together. Now, the industry has more problems than we can count, and you, the community, have told us about the hundreds of challenges you juggle every day. Of course, we won't have time to list them all. To address each of these problems, we will explore the full stack of PassiveLogic's technology and the products built on each of these breakthroughs. We will demonstrate PassiveLogic ecosystem of end-to-end digital twin software tools, including Autonomy Studio, Quantum Lens, Building Studio, Quantum Explorer, and the digital twin training software Quantum Creator. We will get to see in action PassiveLogic's platform for generative autonomy and the IoT hardware that accelerates our building automation installation, including the Hive controller family, Cell software-defined I/O, and the Sense family of smart sensor technology. We will explore the key concepts behind the Open Quantum Standard, the first digital twin language for composable AI. And finally, we will take a deep dive into Differentiable Swift and the breakthroughs in AI performance that drive our platform. We often get told we are like 10 startups in one, crazy or both. because of the unprecedented scale of the team's ambition. But you've told us that point solutions won't change the game, and we believe you. We are all here for one reason: to change the game. And as we take you on this journey through each of the layers of our product stack, we're excited to have the participation today from many of our awesome partners and collaborators. We'll have product demonstration spotlights with some of the world's largest players in real estate, including Brookfield, Prologis, and UDR. We'll also have technology demonstrations and discussions with our tech partners, and we'll also hear how PassiveLogic is changing the game for you, the industry's largest integrators, general contractors, and automation distributors. It is such a rare opportunity to be able to disrupt one of the world's largest industries, and it's even rarer to do it with such strong support of the major customers in that industry. Let's get started. In our digital twin workflow journey, our first stop is Autonomy Studio. Autonomy Studio reinvents how we design, engineer, automate, and manage the built environment in one single end-to-end solution. I've given Tyler and his team the mandate to take AI where it's never gone before and give it tangible form.
To bring generative autonomy to the masses, you need great tools. Tools that make AI and autonomous systems accessible to everyone. And more importantly, tools that speed up our projects, reduce common errors, connect all of the stakeholders, and de-risk system deployments.
Autonomy Studio turns what used to be weeks of programming, commissioning, and user interface graphics into just minutes of work.
That's right. You can fully design a custom autonomous system in a fraction of the time of programming conventional control sequences. And it's completely built on digital twin foundation. Because in order to control the physical world, you've got to be able to describe the physical world.
And to enable this, you need an incredible user experience that's both accessible for novices and also makes experts more expert. We call this progressive disclosure, and we've worked really hard to ensure everyone's included. Autonomy Studio completely reimagines how automation platforms should work, and at the same time, we've been really attentive to making sure it works the way your business already works, so they're aligned. We aren't just automating automation, we're automating your business workflow so you can focus on the high-level design and business critical strategy and quit being distracted by low-level implementation details. In fact, we've spent the last several years collaborating with many of you, the world's top integrators and distributors, to address your pain points and solve the overwhelming challenges of aging incumbent solutions.
And that's not just us saying it, that's you, the industry. Just doubling down on existing solutions isn't going to solve energy efficiency. It just hasn't worked. The existing building automation solutions, they just don't scale. Band-aiding the current solutions has failed the mandate of achieving our energy goals. Controlling the most complex systems in the world with the available technology has kept smart technologists from wanting to enter the market.
On the flip side, many of you who've received early previews of Autonomy Studio have noted how we're eliminating the painful drudgery of today's BMS workflow and shrinking deployment time by over 10x.
Autonomy Studio is a wholly new category of software. It's generative, built completely on digital twins. It enables you to describe the autonomous environment, the building, and the inputs, or IoT. It has a full set of tools for designing your controlled systems, the output side of the equation. It provides automatic commissioning and autonomous management and operation tools in one end-to-end workflow.
And man, did we load it with a huge set of features like floor plan tracing, project costing, design checking, automated point mapping, wiring analysis, generative control system design, and self-healing I/O. And with digital twin-based design, asset management tooling comes for free. Autonomy Studio provides real-time analysis not just analytics and deep ESG insights, all automatically.
We divided the Autonomy Studio workflow into the stages of a building project's lifecycle: survey, design, commission, and deploy. So let's walk through each stage of the workflow. We'll start with an award-winning residential project that runs on PassiveLogic's platform, and then we'll scale it up to one of the tallest buildings in the world. Our first step in Autonomy Studio is to train a digital twin on our environment. This will be the space that our autonomous system will be operating within. We can do this several ways: by scanning, importing BIM, or just by drawing. In this case, we found some prints of the house plans and imported them. Here we can see Zora is just tracing the floor plans to define our autonomous environment. In Autonomy Studio, the generative digital twin inherently understands the concept of interior and exterior walls, and will automatically adjust your digital twin as you draw. In the floor plan focus mode, you can work both in an uncluttered 2D plan view or fully interact with your project in 3D. Once your building's zones have been defined, you can make any modifications you'd like to the design, for retrofits or for remodeling a project.
Now that our as-built model is complete, I'm working with a homeowner on a new addition. Autonomy Studio allows us to separate the architectural design intent from the generative control design environment, which let us experiment with placement while the digital twin automatically updates as we go. We can switch between 2D and 3D to see how our new addition aligns with the rest of the house.
Thanks, Zora. We put a lot of work into making design time productive by eliminating all of the time-consuming 3D orbiting and navigation challenges you find in typical CAD systems. And once we have a new zone in place, we can map the location model of the sensor to IoT devices within the environment model. This trains the input side of our autonomous system. After we have identified the zones, added our new addition and IoT, we can revisit the building as a finished and accurate digital twin in 3D. However, Autonomy Studio isn't only ideal for residential spaces. Let's move to one of the tallest buildings in the world, Brookfield's 1 Manhattan West, to showcase the next stage of our workflow. The next step in Autonomy Studio is to train the digital twin on the systems we'll be controlling, or design a new system from scratch. Systems are the output points that the Hive autonomous platform will ultimately automate for us. Autonomy Studio gives us the tools to engineer, design, or visually copy an existing system, and it's as simple as dragging and dropping equipment from the library. Here, Mitch is diagramming the building's main plant to define the system we'll be controlling. By connecting digital twins together, you define relationships between equipment to form systems. And Autonomy Studio scales to any system, any building, and any complexity. So no matter how complex your building, the underlying quantum AI engine identifies all of the possible subsystems so the Hive can coordinate their control.
All I need to do is identify everything in this mechanical room and how it's connected. What's cool about designing in Autonomy Studio is that every piece of equipment is a quantum digital twin. So it's not just a picture of the object, the physics of how it operates is also embedded. And with Quantum Sync, I can collaborate with the rest of my team from literally anywhere in the world. Now that I've finished the system design, I'll hand things off to Tyler to make any modifications or start designing the control system topology.
Thanks, Mitch. By the way, nice mechanical design. Let me head over to my laptop for the next steps. I'm going to add one more sensor. There. While the Hive platform will always synthesize analytic points via sensor fusion, now I'll be able to get improved data quality. With PassiveLogic's digital twin workflow, user interfaces are automatically generated, so there's no additional graphics effort required. If you want to create custom user interfaces, Autonomy Studio comes equipped with tools to quickly design your own. Add your own images, and even drag and drop variable readouts, inputs, subsystem toggles, or organize them into heads-up displays. The next step is to design the control system topology. Like all of the features of Autonomy Studio, this one is built on the key premise of automating your workflow, but always enabling users to customize the automation and make their own decisions. I'm going to have Autonomy Studio generatively design the control system, and after, I can customize it if I choose. In just a few seconds, Autonomy Studio will create the wiring plans, system network diagram, and automatically point map our I/O. Once we have those in place, we can head to the IoT store to generate a bill of materials, buy zone licenses, and connect to local distribution partners to purchase our desired combination of equipment and systems. Similarly, PassiveLogic's Solution Store enables third-party applications to integrate with our platform. Because everything is built on quantum digital twins, applications, solutions, and services are just one click to integrate. This accelerates software integrations by removing the biggest barrier: integration engineering fees. Now that I have the controls designed, I can have the field engineer commission the system and validate the install. Because Autonomy Studio understands the underlying physics, it can commission the system automatically. It provides wiring guidance, fault detection, and install feedback in real time, saving days, or on a large project like this, weeks of time. While commissioning, Autonomy Studio is checking the building's controlled systems against your digital twin design, looking for any install errors and equipment faults. First, Autonomy Studio commissions each piece of equipment. Then, it commissions all subsystems as a whole. Next, it validates the sensor wiring, cross-validating each of their outputs relative to the building thermodynamics. Finally, it checks all your sensor placements to ensure that they are in the correct zones. Any found issues get badged with an error or a warning, and the reason for the fault. Because Autonomy Studio exposes the hidden problems, this allows you to focus your efforts where it's needed, solving problems. Oh, and it looks like we have a small install error. A valve failed commissioning because it had a reversed interface. Autonomy Studio already has a suggested repair, and Mitch is accepting it right here in the software. There, we're done with commissioning. Now that we've passed commissioning, Autonomy Studio allows us to deploy the system. Thanks, Mitch. Thanks for your help today. Once a building system is online, you can view any building in your portfolio, along with a general summary of its status. Autonomy Studio provides real-time controls without any extra work. Building analysis and ESG dashboarding are automatically generated. The runtime management is unlike anything else that exists in the industry today. First, the digital twin decision engine autonomously generates control paths, making decisions in real time as it adapts to the dynamics inside the building. Simultaneously, it employs always-on commissioning to continuously learn right inside the building. The analysis screen provides information about not only what has happened, but why the control platform has made specific decisions. It also tells you what will happen in the near future and how confident it is in those events occurring, with the data to back it up. And with Autonomy Studio, ESG isn't just a buzzword. It's hard data, automatically benchmarked for you. To talk more about how these tools change the game, here are a few of our partners.
I see PassiveLogic really being a start-to-finish solution to really all of these problems, because you have one program that you're going to basically tell it, here's my system, here's what I want to do, and it's going to do the design. It's going to help guide the installation in a very simplistic way that democratizes it so that anyone can really do it.
When I introduced PassiveLogic to our team, the first thing was wow, right? So because PassiveLogic has all in one, like almost like 10 startups or 10 companies all in one place and then have the full solution as a one company.
So the idea is to be able to take this digital twin type technology and be able to do more remotely, because we're doing more podding these days. We're trying to run large real estate assets, remotely or regionally, and this kind of technology could help us do that.
The PassiveLogic control technology opens up the market to just an enormous amount of customers who never had access to this type of technology before.
If you could solve half of what you're talking about solving, you will absolutely transform our industry. The vision is remarkable, and then the ability to achieve those things is equally remarkable.
Today, we are reinventing the BMS, built from the ground up completely on digital twins. The Hive platform consumes the digital twins from Autonomy Studio and generates autonomous control. It changes the game for how we build and deploy automation for the built environment and industrial world. And most importantly, we built the Hive for you, contractors and integrators, the doers that make the real world go for the rest of us.
That's right. Over the last several years, we've been working with integrators, contractors, operators, and managers. We've asked you, what are the challenges you face with today's automation platforms? And boy, did you tell us your problems. There are a lot of them.
When we set out to design the Hive, we decided to start with a clean sheet. No slow industry evolution or technology shortcuts. It's time to address the major challenges the industry faces today. We started with empathetic design, how the world should operate, and worked backwards to technologies that enabled those design ideals.
The Hive is the world's first platform for generative autonomy. Now almost anyone can build their own custom autonomous systems. It reduces time to deploy an automation solution by 10x. The Hive is designed to be fully scalable across commercial, industrial, and multifamily installations. It addresses any building, from the smallest coffee shop at a sub $2,000 price point, scaling to the largest commercial buildings in the world. And with the Hive, we finally have a modern replacement for the BMS, providing everything you need to automate your project in a single, pre-integrated box. We packed it with a suite of breakthrough features, like real-time control pathfinding, a distributed control engine to bring unprecedented reliability and redundancy, on-the-fly protocol switching, and in-wall mounting that frees automation from the control room. The Hive platform isn't just a BMS with the brains of an autonomous system. It replaces your whole panel. It's a single, pre-manufactured, out-of-the-box solution, saving thousands of dollars and days of labor before you even get started. But because it's software-defined, it can be configured for any use case. For the first time, you can add cost-effective building automation to any project, no matter how small. From unboxing to install to automation, you can deploy the simplest project in under 20 minutes. The only question now is, how many do you need? We made the Hive a modular and fully distributed control system. An industry first, one platform you can scale to any project. You can use 1, 10, 100, or 1,000 Hives. The question is, how big is my building, and how many I/O and user access points do I need? And how many Hives you need is easy to answer, because Autonomy Studio's generative design workflow already figured it out for you, early in scoping a new project. Every Hive comes with an industrial-grade capacitive touchscreen with Autonomy Studio built right into the controller. The tempered glass is 4 times thicker and much stronger than a typical mobile device. And we engineered an incredible sliding screen mechanism, a first. The screen slides up and out of the way, transitioning to install mode, where you have I/O access and can follow the guided wiring, digital labeling, and real-time commissioning on the screen. With the built-in touchscreen, you can quickly install simple projects right on the Hive from project start to completion directly after unboxing. And for larger installations, after designing a project in Autonomy Studio in the office, you can finish the process in the field right on the Hive. Or, if you choose, share your quantum project across teams or with your distribution partner to automate your workflow handoff from design through install and commissioning. So building projects become digital assets connected through their whole life cycle. For the first time, the BMS can be freed from the mechanical room and installed where it is most convenient. The Hive doubles as both an autonomous control system and a user access point. With Autonomy Studio on board, you can switch from project setup to runtime user control in seconds. With the Hive's unique software-defined I/O and distributed control architecture, we are now able to put control and wiring right where we need it. We can install the Hive conventionally, as you would expect, in the mechanical room, either in-wall or with our optional surface mount wiring frame, which enables more organized wiring and the clustering of Hives. But with our distributed control architecture, the Hive can go where no controller has ever gone before: public places. The Hive's unique in-wall mounting system allows placement in any standard 4-inch or 100mm wall cavity. We've built a beautifully designed 4-point wall retention system right into the Hive. For strength, each clamp is machined out of 6061 aluminum and capable of clamping up to 30mm of drywall thickness. By enabling controls to go where the I/O is, instead of home running all the wiring to an HVAC closet, we've halved the wiring effort of a typical install, all while giving you a free user access point at each Hive to manage the system. A huge savings. And even with all of the compute power on board, each Hive has a completely sealed chassis, radiating the heat through a cast aluminum back panel. Super strong, the Hive's metal back also serves to protect from any strained nail or screw penetrations. Amazingly, we were able to design the Hive to amplify heat removal when placed in a wall. The surface of the Hive's aluminum back was simulated and engineered to improve convection inside of a wall cavity to efficiently transfer heat from the Hive to all the wall surfaces. These features are just the start of the details we've invested in to solve the challenges we are all experiencing daily in the field. Now, Austin is going to take us deeper into the Hive's approach to networking and I/O.
Thanks, Alexa. As Alexa introduced, the Hive is a whole control panel in one pre-manufactured box. That includes all of your low voltage power supplies, high voltage, and busing. No more hours spent building up panels and wiring. Everything you need to drive your I/O is built in directly on the Hive platform. We engineered it for flexibility. Just supply any line voltage from 90 to 250 volts, and it generates all the AC and DC voltages required to interface to a huge range of I/O. There's even a low voltage power option, just for use in restrictive jurisdictions. Oh, and that 5-pound 24-volt transformer? Gone. We've engineered an innovative, compact electronic inverter that fits into a square inch of circuit board space to supply up to 50 volt amps at 24 volts per Hive. When we slide the Hive screen up to set up or perform maintenance, all high voltage is automatically turned off. After sliding the screen up, we are in Autonomy Studio's guided wiring mode. From here, we can interactively wire, change protocols, test, and validate our I/O. We've eliminated the need for panel wiring and guttering by busing control signals and power for up to 8 cell modules. That's 48 physical points in one box. And when we close the Hive, it securely locks in place, switching to user access mode. To re-enable design mode, only qualified users with a Hive key and the proper credentials can access the wiring panel and make changes. Surveying integrators, we found that as many as 70% of service calls were due to networking and IT issues, not controller faults. At the same time, the world's security risks are growing as the number of IoT devices multiply in our buildings. And the number one comment we hear is, how do I get IoT devices off our corporate network? So we built a self-managed industrial Ethernet network right into every Hive, so there's no IT expertise required. The Hive uses a new concept called graph networking that automatically clusters any number of Hives into a single system, no matter what network topology you choose. And all of this technology is built on top of IPv6, so it's compatible with your existing infrastructure. Each Hive comes with 4 Ethernet ports behind a magnetically latched door that, just by snapping shut, provides strain relief to secure your cables. All you have to do is connect any group of Hives together, and they will automatically elect a leader, resolve the network for the most efficient topology, and secure all of your IoT devices behind a privately managed device network. and any way you connect them, they'll figure it out. Hives can be daisy-chained or looped to provide redundancy. No matter how many you add and how complex the looping, they'll resolve the best network topology in seconds, and then heal network faults in less than 50 milliseconds. While this feature greatly simplifies the control system networking, it also provides scalable edge computing. Remember, the Hive is autonomous. That means all the AI is working privately in your building at the edge. So the larger the building, the more I/O. The more I/O, the more hives. And the more hives, the more processing power you have for the AI cluster. And every Hive comes with an 8-core CPU and a 1,000-core GPU. So even a small install of 10 hives assembles over 10,000 total cores of compute, which is some serious processing power. And to support retrofits, the Hive comes with Wi-Fi and Bluetooth mesh right on board. No wires necessary. Now sometimes you need free-range I/O, the ability to control in remote locations, or manage a VAV box, or improve your wireless IoT coverage. So we shrunk the Hive down to make the Hive Mini. It takes up to 2 cell modules for a total of 12 points, and has airflow pickups and Bluetooth mesh built right in. Whether you use the Hive or the Hive Mini, we've made I/O a totally new experience. With the cell, we've shrunk the BMS to fit into the palm of your hand. While the Hive is an autonomous platform that replaces the control panel, cells are smart, software-defined I/O that replace the BMS. And they're modular. No more running out of the right kind of I/O and needing a completely new field controller. You can mix and match to meet your needs. They come in 4 flavors: multi, relay, power, and motor. Just pick the one you need and slide them into a Hive. The Hive instantly recognizes the cell module type and updates the digital twin to match. Or let Autonomy Studio's automatic point mapping intelligently select which cells are needed to fulfill a design. It's that simple. Cells allow you to define your I/O at any point in the project. So as you may have noticed earlier, Zora mapped sensors as she designed her digital twin. Yet early in the design stage, she wasn't burdened to know which type. She just knew she needed one. With Autonomy Studio, we can wait to define a device's protocol once we are on site, and we call this late binding. It allows us to adapt in seconds to the realities we find in the field. Each cell flavor supports a wide range of interfaces, and you can choose between them using on-the-fly protocol switching. With the multi-cell, every terminal can be changed on the fly, from BACnet to 0 to 10 volts to 24 volts to Modbus and even Belimo's MP bus, and many, many more. In fact, the same multi-cell terminal can be configured to measure up to 240 volts AC. So we could, for example, monitor voltages in a breaker panel. To do this, we use a concept called semantic lowering that converts the high-level intent of the digital twin control engine to the low-level semantics, or language, of a given protocol. We design the cells around this custom toolless connector that can adapt to almost any wire size, from 10 gauge all the way up to 26, so no more stripping the flathead terminals on standard controllers. But one of my favorite features is the built-in line checking. It solves one of the biggest challenges in install controls: wiring errors. We can check for miswires, short circuits, or know that wires have been cut in the middle of the wall. And once your control system is running, you get real-time power, voltage, and current monitoring on every connected device, generating rich datasets just by controlling it. The cell modules provide guided wiring during the install process, digital labeling above the Hive screen, and visual status indicators on the cell's LEDs. When wiring errors are detected, notifications allow you to fix the install right on the screen. Today we've covered just a few of the incredible Hive and cell features, but you'll really want to experience it hands-on. I'm going to pass it back to Troy to take us through the Hive control engine.
At PassiveLogic, we like to demystify AI for the rest of us, to unmagic the box, so to speak. That comes with a small caveat that sometimes the line between last year's magic and this year's innovation is often very hard to distinguish. The PassiveLogic team has been on fire. Last year alone, we were one of the largest private patent grantees in the Western United States. The Hive platform takes a new approach to automation, and because prior autonomy solutions have been trained for single purpose, we needed to build a whole new approach to enable generative autonomy. This required an innovative architecture. We wanted to achieve full autonomy and also deterministic control execution. We wanted highly scalable sensor fusion and also fully decoupled containers and processes that provided industrial safety guarantees. So the Hive platform is built on a modern functional reactive data-driven architecture backed by an industrial-grade data store that provides high consistency yet separates the linked control engine interests into independent processes. Our autonomous decision engine finds the optimal control paths, coordinating all the subsystems building-wide. This is done systemically, generating a concurrent set of control paths for each subsystem. Those control paths are then handed off to the control executor process that deterministically applies the control outputs coordinated across all the cell I/O in the cluster of Hives. This technology is built on a new heterogeneous neural net structure called deep physics, which is defined by the quantum digital twins. We use differentiable computing during our runtime inferencing to effectively change any direction that we want to compute that same digital twin model, allowing us to solve for different questions during the decision phasing while only having one trained model. Control decisions are made in phases that solve for environmental resources and goals. First, we inference the initial state estimation. Then we inference the resource modulation requirements to all the spaces, resources like heating, cooling, air quality, energy, and so forth. Next, we perform ontological analysis. This is the high-level decision-making that decides what system and equipment should be used to solve the current goals, and why. Then we apply this analysis to create an ontological corridor in the exploding universes of potential future control paths. And then finally, we perform an algorithm called canyon running, which is a form of time-step animated gradient descent down that ontological corridor. And all of this is performed at the edge. Why is PassiveLogic bringing super fast processors to a thermostat fight? Running all of this takes powerful compute. Autonomous means, by definition, that the system runs at the edge, untethered from the cloud to enable real-time control and networking resiliency. And achieving level 5 autonomy takes real computing power under the hood. So PassiveLogic collaborated with NVIDIA to supply the Hive with the world's most powerful compute for AI edge processing. I have the pleasure of introducing Amit Goyal, Head of Embedded Edge AI Product Management and Robotics Ecosystem for NVIDIA, to tell us about the processors that power PassiveLogic's Hive platform. Amit?
Today, NVIDIA is truly powering the AI revolution. And this revolution is not only occurring on the cloud, it's also driving incredible innovation at the edge, in robotics, digital twins, autonomous machines, the physical environment, and more. The NVIDIA Jetson Orin modules that power the Hive have the same Ampere architecture as the Tesla line of GPUs that power AI applications in the data centers and public cloud around the world. This brings the entire NVIDIA AI software ecosystem to the edge. At the core of the Jetson module is the NVIDIA Orin SoC that has 8 A78 CPU cores working in conjunction with the 1024 Ampere GPU cores, 32 third-generation tensor cores, and our second-generation deep learning accelerator to deliver 100 trillion operations per second or TOPS of compute power for AI. So, a 100 Hive scale install in a building delivers a combined 10 peta operations per second of compute processing power right at the edge.
The computing power delivered by the Orin processor allows us to make building control decisions in real time, and we utilize that power to make proactive, future-forward control decisions, no longer limited to reactive control. Now let's talk about quantum, which powers the Hive platform. Today, we've seen all of these breakthrough products, including generative autonomy, that are all built on a foundational technology, digital twins. So what is a digital twin?
It's not just BIM in the cloud.
Right, a true digital twin must be all of the above, not just visualizable like BIM, but also queryable like a time series database, or simulatable like a physics engine, callable like an API, trainable like deep learning, enable real-time collaboration, and be composable and scalable, have a normalized ontology, inferenceable like a neural net, and it must be introspectable like a semantic graph.
Most importantly, it's a language for describing autonomous systems, but it's also general purpose and solves so many of our industry challenges. We need real digital twins that solve the real technical challenges the world is facing. Digital twins that can take us from a world of CAD, BIM, and paper drawings to a world of AI, operational workflows, and digital transformation. We need one standard for the whole building lifecycle.
Let's face it, BIM has been a failure. It's a remnant of the 1990s object-oriented design, and it's not prepared for the AI revolution. And prior digital twin efforts have been mostly hand-waving, like BIM with an extra feature or two. In fact, so much of what's been pitched as digital twins serve up zero actual content. And with today's standards focused on labeling and category semantics like haystack, brick, and backnet, we lack real ontology. The metaverse in and of itself won't be a primary business driver. We need digital twins that solve real problems. And for these digital twins to be useful, they need to reduce work, not create more work.
Quantum provides one standard, a single data model for the whole life cycle of the project, from sketching, design, engineering, install, maintenance, and service integration. We've merged deep learning with physics to create the first physics-driven ontology, not just another semantic standard. The quantum standard is AI first, designed for the future. It's the first AI network description format that's fully typed, allowing runtime composition, a true breakthrough in how we structure AI applications. The Quantum API provides the first high-level API for buildings with no extra work required to bind it to your control system.
Quantum Sync provides real-time data sync across applications and building systems. Every one of the solutions we're featuring today speak quantum, from end to end and all in real time. Semantic lowering converts or lowers the high-level decision-making intent of digital twins to the lower-level protocol semantics to solve the IoT communications Tower of Babel that we face today.
As the first ontological standard for physics, quantum structures the world and its objects into behaviors, components, actors, and quanta. What's an ontology? I promise this will be one of the few nerdy words we are going to use today, but it's a really important one.
One of the few? We've been pretty nerdy today.
Our goal is to demystify how PassiveLogic's technology works, and ontologies are one of them. It's an idea invented by existential philosophers 400 years ago to explore questions like, what's my purpose in life? Why do I exist? While this is heady in AI, these ideas are super important. Like, what's a pump's role in a system? What's a door's role in a building? Quantum is the first standard for digital twins. That's a physics ontology and built on graph theory. It's a data model, an ontology, and in-memory compute graph that supports AI inferencing all in a single format. It enables conceptual sketching of buildings and architectural design and modeling. It makes generative building design and mechanical engineering possible. Using the same model, we can simulate physics. In AI, simulation is what we call a deductive inference, meaning that I'm going to deduce what will happen in 1 minute, 1 hour, or 1 day from the current conditions. Quantum is super fast at deductive inferencing, 100 times faster than an energy plus simulations, with big speed boost coming. But for the first time in an AI framework, quantum enables abductive inference. Abductive inferencing means that we can first select what future outcomes we want and then simulate in reverse to find the conditions to make that future come true. This advancement allows control pathfinding, generative design, and real-time decision-making at the edge. And today, using abductive inferencing, we achieve incredible performance, 10 million times faster than the next best market solution. So instead of searching through billions of simulation possibilities like deductive inferencing requires, it's possible to do it in one shot, making real-time generative autonomy at the edge possible for the first time. Abductive inferencing solves more than just control. It can be used for a myriad of solutions. For example, 3D printing of buildings to meet the structural design requirements without bouncing back and forth between CAD and CAM. Or generatively designing the best sensor layout for a building, ensuring sunlight won't hit the sensor and cause read errors throughout the whole year. And this is not just for programmers and engineers. We make inferencing available to you, our users, so you can explore new ways to apply this technology. Quantum is built on a physics ontology that maintains the fundamental meaning of each part of the digital twin while making our neural networks fully introspectable at runtime. No more black boxes. To achieve this, Quantum introduces 4 ontological concepts: actors, the role a component plays; quanta, the currency of interchange between components; behaviors, the actions components take; and properties, the substance that components are made of. This ontology foundations gives Quantum what we call in the AI world its own ground truth. In traditional deep learning, you have what's called the observer problem. Has the system seen all the data it will see in the future, and how can you prove that it did? And since each new project is a wholly unique system, it would take decades of observation just to acquire all the data, and then an eye-watering amount of time and money to train AI across whole portfolio of projects. Quantum steps over the AI training conundrum because it doesn't have to reinvent 300 years of the physics understanding and can't go off the rails like conventional deep learning.
This makes Quantum safe by default, allows systems to be deployed without a training period, and enables on-site self-supervised learning.
We are introducing this new concept in AI, ontological frameworks that define the high-level meaning of things in the world. And later on, we'll be discussing types, the low-level atoms of digital twins that allow us to safely snap together AI subgraphs at runtime, which is a really big deal. This concept of composable AI is a first. Where other deep learning frameworks requires models to be trained monolithically, Quantum allows the runtime composition of pre-trained subgraphs.
And this is a huge breakthrough. No more training period before deployment. Once you've built a digital twin inside a PassiveLogic software tool, the AI is ready to go. And we've made Quantum an open standard. Larry will tell us about the growing Quantum Alliance.
Earlier this year, we launched the Open Quantum Alliance with dozens of industry partners signing on. The Open Quantum Alliance is a public-private collaboration dedicated to enabling the future of building technology built on digital twins. Quantum provides the first language for generative autonomy, the first buildings API, a complete digital twin ontology, and quantum object models across multiple programming languages. So why take one of PassiveLogic's key technologies and give it away to the industry? We firmly believe that by working together, we can grow the industry and increase the velocity at which we scale the market, enabling future technologies like autonomous systems. Today, the Quantum Alliance is made up of equipment manufacturers, technology companies, government agencies, cloud service providers, and building owners and operators who have come together to enable the future of buildings. We invite you to join us in reinventing the future. Visit quantumalliance.org to sign up.
Majid and Troy introduced 2 breakthrough technologies that Quantum enables: high-performance abductive inferences and AI graph composition. These are both built on unique compiler technologies we've pioneered at PassiveLogic. Today, I'm really excited to share the AI breakthroughs from PassiveLogic's compiler group, which is today the largest differentiable compiler team in the world. We're building differentiation right into the Swift language, and today Swift is the first systems programming language to have first-class differentiable compiler support. In order to power the leap to generative autonomous systems, we needed to push the limits of what could be achieved with compilers to make this technology possible. Differentiable Swift is a huge breakthrough for AI and makes other innovations like quantum digital twins and generative autonomy possible. Most importantly for developers, you too can experiment with next-generation technologies with the same industrial-grade systems language you may already be using to deploy applications. So what is differentiability? Differentiability is a type of reversible computing that allows code to not only run forward, but also backwards, the enormously powerful technique behind technologies like gradient descent. Differentiability is also the magic behind deep learning, but to date it's been locked behind the big AI frameworks that have a limited point of view. What if we could unlock the potential of differentiability for any code you can dream up, not just conventional neural networks, and for all programmers and their use cases? Recently, our CEO Troy sat down with Chris Latner, the inventor of the Swift language and a founder of Differentiable Swift, to discuss why differentiability is so important.
What we're building at PassiveLogic is this platform for generalized autonomy. And for us, that's how do we take a concept of automation and control and make it general purpose, that the individual end user can drive their own systems. And to me, for a compiler engineer, you guys are all the way at the bottom and you're thinking, how do I generalize these core ideas across everything?
One of the things I love when working on Swift and building out a technology platform is thinking about how do I enable a huge number of people to get access to this technology. Right. And so knowing how they can build tools for these people at all different stages of expertise, different domains, different focuses, and be able to get these people to work together and then be able to make the products they build be the highest performance, best working, most reliable, most predictable products they can have is really pretty exciting, right? And what I'm doing is I'm helping people build and express themselves and give them a canvas to paint on.
So at PassiveLogic, we considered the state of AI tooling and asked ourselves a bunch of questions. What if differentiability could be a first-class feature of a language where you'd get all of the debugging and copilot features you'd expect from your development environment and compile-time native performance? What if we could enable new technologies that don't fit the mold of existing frameworks? What if any arbitrary code could be trained, not just homogeneous graphs like conventional neural networks, but heterogeneous typed computation graphs? What if we could train and perform inference on next-generation technologies like digital twins, just like for deep learning? And what if the direction of graph inferencing wasn't just set at training, but could be chosen at runtime? We need to move beyond black box neural networks and the separation between offline training and runtime inferencing so that edge AI can learn as it operates. And that requires a whole new level of performance. At PassiveLogic, we aren't the only ones recognizing we need a new approach to AI. You, the developer community, have been very clear about these problems. For example, the recent breakthrough in AI isn't neural networks. Those have been around for decades. It's differentiable programming that made deep learning possible. And we are just starting to explore the potential of differentiable computing. Today, much of the AI world looks very similar to each other because they are built on the same frameworks and models with the same approaches. Though existing frameworks advanced AI to this point, they are now holding us back from new possibilities that will take us to the post-deep learning era. The next breakthroughs in AI require a flexible general-purpose language that enables us to build novel solutions. And while currently very popular in machine learning, Python has downsides that limit its use in industrial solutions. Furthermore, we'll never realize the full potential of the AI industry unless we can tear down barriers between AI and industrial applications, where you find the masses of developers who write the world's applications and systems code. Differentiable Swift solves these problems, delivering for the first time first-class general-purpose differentiability built right into the language, runtime composability using a strong type system that provides safety guarantees that are ideal for production systems, no boundary between your production code and your machine learning code, enabling heterogeneous networks, and with fast runtime differentiation, you can both train and perform inference at the edge, enabling runtime solutions like multidimensional inferencing that solves neural networks in any direction. And of course, this is all built on the same industrial-strength Swift language that millions of developers use every day to deploy a wide range of applications. It has great tooling, is available on many platforms, and has native interoperability with C and C++ code. Built with safety in mind, easy enough to be someone's first language, yet possessing powerful features like native concurrency and mutable value semantics, Swift today is a wholly unique language to build the next generation of embedded AI applications. The original design for Differentiable Swift grew out of the Swift for TensorFlow project at Google. As a former member of the Google Swift for TensorFlow team, I'm proud to help carry on that work here at PassiveLogic, where we are advancing this breakthrough feature and upstreaming our work to the open source Swift project. Differentiable Swift enables developers to perform gradient descent through strongly typed code, like the code that powers the abductive reasoning behind Quantum. And I'm excited to announce that we're using it in production today, and it's blazing fast. We have made Differentiable Swift the fastest solution for general AI training on the planet. And we're not just talking a few times faster, but orders of magnitude. For example, in benchmarks for optimizing digital twins, we are 322 times faster than TensorFlow and 232 times faster than PyTorch. By using a fast host language like Swift, we're enabling the compiler to do what it does best, like ahead-of-time optimization. With compiled code, there is no need to dispatch compute kernels, we just perform the calculations directly. We're blurring the line between systems programming and AI, combining them into one domain. Now, incredible AI performance is only part of what we're developing today. For the first time, we can make AI graphs composable at runtime using Swift's type system, a system built on formal methods, something our quantum ontology team cares deeply about. One language from end to end, no complex development pipeline, handoffs, or stitching required. Currently, most AI in research is being developed in Python, but Python was not designed to be a systems language and may not be suitable for programming industrial applications, control platforms, or embedded IoT devices. But Swift bridges all of these worlds. Over the last 2 years, PassiveLogic has built the largest differentiable compiler team in the world to drive this technology that changes how we develop AI applications. And with PassiveLogic's inference tools, we can introspect across any dimension of a network. And we're just getting started. There are endless potential applications for differentiability, and deep learning is just the beginning. Today, we're collaborating with the Swift compiler team to make Differentiable Swift available for all developers on Linux, Windows, macOS, and iOS. We're announcing that PassiveLogic is using Differentiable Swift as a compiler feature in production today. As we all know, Apple uses Swift for its entire product ecosystem, but its modern safety guarantees make it the perfect language for industrial applications. The open collaboration with the Swift community has been phenomenal, particularly the continued design insight of Richard Way, who is a founder of Differentiable Swift as part of the Swift for TensorFlow project at Google Brain.
Differentiability is the breakthrough technology that powers deep learning. Bringing it to systems programmers and application developers has so much potential to positively influence how we code, and for the future innovations we build in AI. You put that together with Swift, a fast, ergonomic language that's designed for high reliability, and it opens up so many exciting possibilities. Let's write a little code. Here's the simple function. In this case, a little bit of physics. I can call this function just like you'd expect, and here's my answer. But I can also call its derivative form called a pullback. See how the code runs backward through the function, right here in the debugger? Pretty cool, right? This concept is the foundation of AI training, but here I'm using it for an arbitrary piece of Swift code. With this feature, any code you write can be differentiated. Now let's bring up the two most popular AI frameworks, TensorFlow and PyTorch, and take a look at performance. I'll even give them a little head start. Swift is done. Still waiting? Okay, they're getting there. That's not done yet. Finally done. Today, Differentiable Swift is 322 times faster than TensorFlow and 238 times faster than PyTorch. Ridiculously fast performance. I'm so thrilled that PassiveLogic is pushing this forward.
Thanks, Richard. It was an honor to work with you on the Swift for TensorFlow project, and we're excited to carry on the collaboration. Next year, we'll be open sourcing more of our graph, introspection, and inferencing libraries. These open new avenues for next-generation AI applications. But you don't have to wait. Differentiable Swift is available today. We invite you to grab a toolchain from swift.org and try it out. We'd love to see what you can build with it. Here's my colleague Adam to tell you about our digital twin application, Quantum Lens, one of the many tools you'll see today developed with Differentiable Swift.
Quantum Lens gives you the power to make, manage, and view digital twins on the go. With Quantum Lens, we can scan and survey new projects, commission installed systems and IoT devices, and store your digital twins for offline use at the project site, and interact with live digital twin data in an active system. Yet it's so easy to use that even a casual user can scan their own home into an accurate digital twin in just a few minutes. Quantum Lens is built on 4 pillars: scanning buildings and equipment into digital twins, commissioning equipment while validating sensor location layouts, viewing system analytics in augmented reality, and providing a digital twin wallet that bidirectionally syncs quantum models from the office, to the field, to construction sites, or even air-gapped control systems that are offline. And within these pillars, we built a ton of game-changing features that improve how we bid jobs, commission our control systems, and manage buildings. Some of these features include on-device scan processing, drift compensation, object recognition, secure mesh network provisioning of IoT devices, offline system management, and bidirectional quantum data sync. With Quantum Lens, we can scan buildings into live digital twins. It opens a whole new approach to our building workflow. Other solutions, for example, Matterport, only scan buildings into non-editable 3D meshes that may generate a gee-whiz 360 cam experience, but offer little functional value. What you've said you want is real geometry, floor plans, and editable models. With Quantum Lens, we generate live models that we can use later for design or generating autonomous systems. And we convert the raw scan geometry into the building digital twin using the differentiable AI technology Brad introduced to us. We do it right on the device, so there's no need for cleanup by an architectural service and no processing in the cloud. Instead, it happens right on the phone as you scan. It's super cool. We designed Quantum Lens to scale. You can scan 100,000 square feet of building into a model in a single day, which is huge. Before Quantum Lens, it required hundreds of thousands of dollars of scanning equipment. And still, you'd have to post-process the point cloud with manual labor. And on the low end, today's mobile solutions are too slow and clunky for professional use, requiring manual reassembly of all the fragmented pieces. We've designed Quantum Lens from the start as a continuous workflow where you can scan from room to room without having to pause, while simultaneously locating key equipment, points of interest, and provisioning wireless sensors, all in a single pass. Today, Caroline is scanning an apartment building in UDR's portfolio. To capture the building, all she has to do is locate the walls of interest within the space, and wall geometry will flood fill into the model. We scan each contiguous room, walking to the next, each in sequence. It totally changes the game for the 85% of existing buildings that don't have architectural plans, and for new buildings where most of the time we don't even have as-built drawings. Whether you are a designer, contractor doing remodels, or an integrator surveying a new project, Quantum Lens is an accelerant for your business. One of the app's key features is that it filters out 95% of the junk in 3D scans that we don't actually care about and extracts the geometry we do care about. No herding people out of the building or shoving all the furniture to the center of the room required. On-device processing keeps your information private by default. Quantum Lens also automatically recognizes important features, such as doors, while excluding unnecessary objects and people to reduce the prep work needed to scan any space at any time. And it allows you to capture points of interest along the way for later reference. Use it to keep track of mid-construction details or equipment nameplates for retro commissioning. You can stop a session at any time. The quantum spatial AI will recognize your location and enable you to restart your session at any time. While you're scanning, Quantum Lens recognizes objects and labels them. Just tap to convert the point of interest to a 3D quantum object. Now, none of this would be possible without spatial drift compensation, which is all processed on device using Differentiable Swift, which Brad discussed earlier. It's really amazing to see AI operating natively on digital twins right on the edge. And the compiler just got integrated into iOS, so expect to see major improvements in the coming months. In addition to capturing points of interest, Quantum Lens can be utilized to commission equipment like PassiveLogic Sense Nanos. As you scan, you can simultaneously commission wireless IoT devices, adding them onto a secure wireless network. This ability to make a building digital twin and onboard sensors at the same time makes small design build projects incredibly fast to set up. In larger projects, Quantum Lens locates sensor install points and validates your installation against the engineering plan of the digital twin designed previously in Autonomy Studio. The end-to-end workflow, from design to install to augmented reality validation, is really magical to see in action. Once your building is in operation, Quantum Lens acts as a mobile management tool for your building. It allows you to drill down into sensors and equipment data inside the building or anywhere in the world. Quantum Lens also provides a mobile wallet for digital twins. It works both online and offline. So for example, you can carry projects into the field and share digital twins with the Hive controller while a building is still under construction, or when a cell service isn't available in a construction box in a basement that a mechanical system sometimes calls home. You can pin digital twins to your phone to ensure they are always available. And Quantum Lens, like all our products, is built on Quantum Sync, meaning as soon as you've scanned a building or made a change, it's instantly available in all your other PassiveLogic tools. And Quantum Sync is bidirectional, so offline buildings or even air-gapped systems that are part of your portfolio can be synced with a Hive installation in just a few seconds, ensuring access to continuous data for even rarely visited buildings.
Once I've added my project to our team's account, we can manage all of our portfolios, buildings, and floor plans in real time, making it easy to inspect our building assets and get operational guidance and insights. Quantum Lens enables all buildings, both new and retrofits. It can unite the management of a varied portfolio regardless of location, age, or use case. You can use Quantum Lens at any point in a project. Today, it's just the start of this building's digital twin journey. Now that I've scanned it, I'm going to hand this project off to Alec, who will make some remodeling changes for me in Building Studio.
Thanks, Caroline. Let's open up your project. Love the building, by the way. Sign me up for a unit. Okay, I'll make that design change for you. There you go. Now, let's kick off a proper introduction to Building Studio. I'm so excited to launch Building Studio. Though we're releasing it today, there's so much going into this tool that it's actually going to take us much of the coming year to roll it all out to you. And even then, we're just getting started. When we initiated this project at PassiveLogic, there was a huge need to reinvent sketching by utilizing a generative AI and digital twin foundation that connects beyond design development to the operational phase of the building. And this end-to-end workflow of Building Studio resolves a suite of challenges that the industry struggles with today. Today, we've been given a devil's bargain. We can use a sketching tool like Trimble's SketchUp, which is sketchy and fast, but has zero building awareness. Or we can use a BIM tool like Revit or Bentley, which are expensive and laborious, and still only deliver moderate building awareness. In our current workflow, most of us end up using a sketching tool to explore our ideas, then throw it all away to start over in BIM. All of this work just to get construction documents, which honestly will be an AI detail in the near future anyways. It's 2023. We can do better. We're spending all of our time getting lost in the pedantic bits of a project, instead of being enabled to design strategically and letting our software fill in the details. It's time to let AI do the work for us. And after 3 decades of physics simulation tools, they still require experts to drive, plus a huge investment. And even with experts on staff, it still takes days just to get a project imported into Energy Plus. If you're like most of the industry, you end up redrawing the whole building because it's just too hard. We can all agree BIM is dead. No matter what alphabet soup of tools you try to string together, there just is no solving the fact that BIM is instantly out of date the moment you draw a building. What if there were a better way? What if buildings could be designed using digital twins? And those buildings controlled themselves using the same digital twins. And then the building's autonomous system could keep us up to date on changes to that digital twin in real time as it operated. And what if we didn't have to work harder to achieve that dream, but could actually work faster and more efficiently? It's time for a paradigm shift. And that shift is built on 4 breakthrough concepts. First, an architecture environment built on generative design AI. Second, instant site analysis and climate synthesis tools. Third, ultra-fast physics simulations at the touch of a button. And fourth, for the first time, PassiveLogic is delivering operational BIM. And we've built so many incredible features: generative sketching, speech to architecture, vegetation and solar shading design, real-time topology excavation, physics-driven design tools, thermal load analysis, and live operational BIM and analytics. With Building Studio, we've taken a new approach to design. Instead of getting mired in the details of drawing walls that only once they enclose an area do they finally generate a room and space, we realize what we really care about is spaces, not walls. So we flipped the workflow on its head. Instead of drawing individual walls, we can simply draw the rooms and let the walls and the building artifacts generate themselves. It's a super fast way to work. Now we can design primarily for functional requirements and secondarily decide how to arrange the building for the best spatial flow. Built completely on a generative foundation, Building Studio creates the right surfaces, wall types, doors, and openings, all automatically. It's not only fast and intuitive, it's incredibly fun. Space-based design also means we can start focusing on surfaces and stop fiddling with corners and vertexes, which makes editing way faster. Today, Kaveen is creating the digital twin for a Prologis industrial facility using Building Studio. He started a few minutes ago in Quantum Lens with scanning the office spaces, and he's opened the digital twin in Building Studio to add the warehouse space, which is a large, fairly simple area that will only take a couple of minutes to draw. Adding windows and doors is generative. Pick a size and the style automatically follows to maintain the user's initial preferences. Building Studio gives us a floor focus, where we can switch between a simple 2D floor plan and a 3D focused perspective editing. And all of our tools work continuously across both views. Then, copy up to generate the second floor. Stack View expands floor plans so we don't have to spend time orbiting and sectioning, and we can focus our time on creating. Changing to 3D, the build reassembles, and we continue editing from a first-person 3D perspective. On the first floor, let's quickly modify the build-out to meet the client's needs. Since this is a warehouse, let's add roll-up truck bay doors. IoT layout allows us to design our digital twin sensors and equipment right in 3D. The Magic Wand tool enables us to generatively create objects. Let's first create an area layout of the structural posts that separate the warehouse bays on a 40-foot grid. Now, since this is a warehouse, we want to inform the digital twin that internal logistics real estate isn't just floor space, but vertical surfaces. Let's generatively add shelves along the perimeter and adjust the number and spacing.
Building Studio is the fastest way to model building, hands down. But what's really amazing is I can place the building anywhere in the world instantly within the context of the accurate local 3D terrain and city model and analyze the shading and climate. Building Studio also automatically handles all of the site excavation. I can raise the building pad upon fill or dig it down into a berm. And when I adjust and rotate its position, the excavation automatically follows. Let's try moving our building into a denser part of the city and see its impact on shading. See how it automatically removes all of the potential site's existing buildings so I can test the potential site. And just as easily, I can simulate the building's physics and see how the building performs, change assemblies and materials, and calculate the mechanical loads. We get all the performance advantage of the quantum physics backend, which is 2 orders of magnitude faster than the market benchmarks like Energy Plus. Plus, it's fully transient and not just an energy balance simulator. You can run the simulation on climate data or pick any time period in weather history to analyze the building against historical conditions for retro commissioning analysis. No more file gymnastics, complex imports, or lost time. Building Studio finally brings simulation to the mass market.
Thanks, Kaveen. Those simulation results look great. Building Studio has a suite of AI-driven design tools from generative sensor layout, constraint-driven design, and natural language to architecture. For example, if I say, design a building that has 6 hexagon rooms and a honeycomb layout, Building Studio automatically generates the building geometry, and afterward, I can edit the building. If I say, duplicate that floor to make it 3 stories tall, it edits my design automatically to match the query. Or we could say something like, now relabel all of the rooms to be a typical office names for a German building. Combining the expressiveness of natural language processing with Quantum's deterministic digital twin AI turns LLMs from fun gimmick to a highly productive tool that embodies the real ontological outcomes of your intent. Super cool, right? Finally, Building Studio does something never before possible: operational BIM. Because the entire PassiveLogic ecosystem runs on the same quantum digital twin, and the Hive is constantly learning on the current state of the building, updating itself to operational changes, and fusing the sensor data, that digital twin is always an accurate reflection of the build state. This means I can open any building in my portfolio from across the world and get the real-time state of that building. I can quickly analyze operations, view ESG data, and finally get visibility into these valuable assets. Today, we've only scratched the surface of the innovations we've built in Building Studio. It's truly going to change the way we design, engineer, and manage our building assets. Now that I've got a digital twin, I'm going to pass it over to Jay to discuss how we can build services and the software solutions for the quantum digital twin ecosystem.
Thanks, Alec, and thanks for the digital twin handoff. Let's see what you're working on in Quantum Explorer.
See my space selection? Could you get me a list of all the windows and their area for this building? I need to take off for my glass order.
Yeah, sure, no problem. Here's a list of the windows and their sizes.
Thanks, Jay. I'm going to place that order. You should tell everyone about the amazing things you can do in Quantum Explorer Pro.
Today we've seen a number of breakthrough PassiveLogic products that provide you with an end-to-end ecosystem of digital twin solutions. What's really exciting is we've shown how we can collaborate in real time, but not just in one product, but across software tools, teams, and domains. And all of this is built on the power of Quantum Sync, which digitally connects all your workflows and enables you to choose your own adventure. You can use just one of these solutions or use all of them, giving you the freedom to accelerate your workflow across the building lifecycle. Tyler showed us Autonomy Studio, a tool that allows anyone to design and deploy their own custom autonomous system, automatically generating all of the operational controls, analytics, and ESG dashboarding, changing the game whether you have one building or a huge portfolio. Adam showed how Quantum Lens can give us tools to scan buildings into digital twins and manage them on the go. Alex showed us how Building Studio accelerates how we design and engineer our buildings, and it delivers on the dream of operational BIM for the first time. Today, I'm excited to show you Quantum Explorer. It enables non-programmers to query and inspect quantum models, perform digital twin AI inferences, and perhaps most importantly, finally gives programmers a real digital twin integrated development environment, or IDE, to develop the next generation of applications and services for buildings. And it fills a critical void. The building market is the largest industry in the world, and it lacks a high-level API and developer tools to make solutions. Today, expensive integrations are a barrier to so many use cases. It's time we scale the building market for the growing ecosystem of prop tech, construction tech, and climate tech companies that need one-click integration to buildings. Welcome to Quantum Explorer. It is built on 3 key pillars. First, the only unified high-level API for buildings, and a digital twin IDE to drive it. Second, a suite of quantum ontology tools for visualization. Third, a user interface for making AI queries that allows you to explore real-time information to answer any question you can imagine. Quantum Explorer allows you to visually navigate the quantum ontology. It serves as the atlas to the quantum digital twin standard. You can navigate quantum domains, objects, and relationships within the hierarchy, or visualize them in the Graph Explorer. As we saw earlier, you can link it to a live quantum project and collaborate, or you can build queries that can be applied later to any building. We can build these queries visually just by dragging and dropping the quantum components into the query builder. It only takes seconds to get answers to any question. Imagine I was told our office areas are stuffy and I needed to know the air changes for those zones. First, I find all the office zones in the buildings. Nice. I can also chain queries together to extract complex information. Next, I'll find the volume of all those office zones from the previous query. Excellent. I'm going to hand this off to the building engineer who can use these results to make adjustments to the ventilation. For the developer, we generate code in GraphQL and we give you a visual IDE to interact with the Quantum API. It's a complete digital twin coding environment with Quantum autocomplete. And we don't stop there. You can make AI inferences. We expose the Quantum Inference Engine to you, the developer, so you don't have to spend years building a team, training models, and developing a building-aware stack. Let's try one. I've got a high-temperature zone in my building. By traversing the ontology, I can discover that this is caused by a stuck VAV damper. That's super cool. Explorer allows us to visually introspect a digital twin graph and link it to an active project. It gives you a visual debugger for development. Quantum digital twins are real-time representations of their actual world counterparts, meaning that the information contained within them is always up to date. So any query you make in Quantum Explorer is live. The information you get back is what's happening right now. Quantum Explorer and the Quantum API allow us to write once and deploy everywhere, which changes the game for the building industry. No more $50,000 building integrations just to enable analytics, ESG, or corporate operational software. Quantum Explorer also allows you to test your code. You can develop against a suite of example projects and apply these queries to any building within your portfolio. It's so easy to build universal services and apps with the Quantum API. Next year, PassiveLogic will be rolling out the Quantum Solutions Store, enabling you to deploy your solutions to end customers and manage subscriptions. For in-house use, you can keep services private, accessible only to those within your organization. So to recap, today you can access Quantum Explorer, which introduces several new digital twin innovations. The first unified and high-level API for buildings, a visual query builder, AI inferencing queries without training new models, an ontological explorer, introspection and testing tools, and Quantum Sync hot linking to live projects. This is the start of a revolution for the built environment. Finally, the industry can make solutions that scale and can be attached to any building with a single click. Now, to extract all the insight we want out of our buildings and fuel the Hive sensor fusion engine, it's useful to have richer sources of data. To make that easier than ever, PassiveLogic has developed some incredible sensor technology. I'm going to hand it off to Marciano, who's going to introduce the Sense family.
When we set out to build the PassiveLogic platform, the goal was to build the brain for buildings and to connect to all the sensor and emergent IoT tech on the market. Now it's important to note that goal hasn't changed. We have some really great partnerships with a wide range of smart sensor and IoT companies in the Quantum Alliance, and it's growing monthly. But you, our community, who used the Hive under NDA said, can you build a companion sensor that achieves the same design goals as the Hive and speed up our install workflow?
PassiveLogic is about platforms that simplify your life. So we decided to build a killer sensor that put the brains of a building scientist in the palm of your hand. And because at PassiveLogic we don't do anything without overdoing it, we did it twice. Meet the Sense Nano and the Sense Touch. The Sense family was designed to solve 4 major challenges, so we bring together one device with the full spectrum sensor tech in a beautiful package, wireless everything, including power, a fast 30-second install, and built-in location services, so we can provide adaptive comfort. The Sense Nano brings together 7 sensors in a tiny, architecturally beautiful package. Temperature, radiant temperature, humidity, air quality, light level, pressure, and occupant location services. And the Touch adds a radiant camera for temperature distribution, motion detection, CO2, and sound pressure for a total of 11 sensors. You can install the Nano in under a minute. It's as easy as stick, twist, and click. The Sense Nano is the first truly wireless sensor on the market. Other wireless sensors require a battery that will run out, or wires to provide power, making them not really wireless. The Nano is powered by stray light from its environment. Behind the white diffuser that helps blend into its surroundings, it has a solar panel tuned for visible light spectrum, the kind of light that is generated by indoor fixtures. And it works in the lowest light environments, down to 25 lux, which is half of the International Building Code minimum requirement for unoccupied spaces like fire escapes. It's a remarkable achievement of low power engineering. The Nano also has a full year's worth of backup battery on board and dynamically manages power and transmit rates so that even with very intermittent sources of light, it can power itself indefinitely. And you, our loyal customers, have told us that the industry is increasingly at odds with its owners, architects, and tenants over the ugly plastic enclosures that house today's thermostats and sensors. Old-fashioned wall warts have to go. Our industrial design and electronics team work together to miniaturize the Sense family electronics, bring together unobtrusive minimalism and beautiful functional design. Made from CNC machined aluminum and a clear anodized textured finish, it fits into any architectural space. And we built it all with a superset of Bluetooth mesh, an industrial standard for secure and resilient wireless devices. Like Bluetooth, it's compatible with all the world's mobile devices and adds a new feature, wireless mesh hopping, without power wires required, which enables long-distance networking. However, today, Bluetooth mesh isn't appropriate for ultra-low power devices because of its flood-based architecture. So we developed a new concept in Bluetooth mesh, rivers. Rivers are backwards compatible with flood mesh networks, but divide devices into chains that wake up and act synchronously, what is known as time division multiplexing. Provisioning the Sense family is super easy. As you saw in Adam's demo of Quantum Lens, it can be done on the fly as you make a digital twin of the space, precisely locating it in the model. And we use a unique out-of-band secure method to wake the Nano up from deep sleep, a manufacturing state where it can retain battery life for years waiting to be deployed. We securely pass network keys over a beam of light, so setup is kept out of range of potential hackers. After setup, all the sensors in the building get fused together to generate a single digital twin view of the building, so that we can interact with it via any part of the PassiveLogic software system. And at any time, if we want to query a specific nano in the field, just walk up to it with Quantum Lens, and you can quickly interrogate any sensor for setup and site debugging purposes. With the Sense family of sensors, you can choose a gorgeous Go Anywhere self-powered nano-sized sensor, or the stunning Touch, a visual OLED touchscreen display that directly engages you. We developed this incredible Radius Glass Touch interface with a thermal camera mounted behind a flush black silicon window. While the Nano uniquely has a calibrated mean radiant temperature sensor, a $600 value, the Touch brings a whole thermal camera with a fisheye view of the surrounding space. And it adds a CO2 sensor on top of its VOC sensor, giving it a broader view of air quality. To add to that, we've added sound pressure level detection so we can adapt to duct airflow noise. And because we're based on Bluetooth, each sensor acts as a reverse beacon to provide indoor location services for BLE devices. This can be used in so many different ways in the PassiveLogic building platform. One of those ways that's most important to us is occupant comfort management. See, the Hive controller doesn't just control air temperature like a thermostat, a technology that hasn't changed since the 1800s. Air temperature is only 20% of the information you need to even describe comfort. It's a completely out-of-date approach. Instead, the Hive controls a building to meet our comfort, using human physiological digital twins as a control target, meaning you and me. And if I want the building to adapt to my needs, it needs to know where I am, who I am, and what I like. That's where Passport comes in. In the coming year, we will release Passport, making digital twins very personal. Super cool, right? Passport puts your personal identity right in your pocket, so you can control how much you share, build your own personal physiological digital twin, and open the door to access control. Given that digital twins are so important, how are we going to make them all? To round out this year's keynote, Sarah, who leads Quantum Creator Development, is going to show us how to build digital twins at scale.
In the last few months, the world started buzzing about digital twins. The question is, how are we going to make all these digital twins when there's no digital twin software? And given the world of digital twin applications that we've introduced today, that question is even more important at PassiveLogic. So, how can we make digital twins at scale? The industry isn't going to do it one PhD dissertation at a time. We need a way for all of us, and especially equipment manufacturers, engineers, and researchers to build digital twins quickly and easily. To make this possible, we developed Quantum Creator, a new type of CAD system for building and training digital twins. It was developed to address 4 major needs in the market. First, a visual tool for building digital twins. Second, an ontological physics modeler. Third, AI training of digital twins. Fourth, an environment for making accurate quantum-first models. And we've built a suite of features including equipment and component modeling, a live typeset math editor, validation testing, templating, datasheet extraction, and super fast differentiable training. Quantum Creator is built to design digital twins, and we'll start with the easy part, drawing. It supports all of Quantum's digital twin composition concepts at multiple levels of hierarchy. Assemblies are things like a chiller or a VAV box, or other complex equipment composed of simpler equipment. If you want to make a custom assembly, just draw a subsystem diagram, similar to Autonomy Studio, to generate an assembly graph. Then expose proper quanta connectors and choose what actor quantum conformance your custom assembly will inherit. Similar to building assemblies, equipment are built from components which are composable of atoms and quantum. A pump is an example of an equipment, and it's composed of a motor, pump body, and a control interface, which are the smallest functional parts or components we can break down. Components, therefore, are the lowest level container that have a typed role in the ontological universe. We call this the actor quanta conformance, which defines the component's purpose in an autonomous system. Given that most of the industrial world is made up of less than 100 common components, for most engineers, composing equipment is the lowest level design you need to interact with, and most of these are going to be found in the quantum library. But for manufacturers and researchers, you can create new components or edit existing ones. After drawing your digital twin symbol, you select an appropriate actor quanta conformance template, and it automatically sets up the required neural network to meet the minimum requirements for the given actor quanta type. For AI researchers, this means it defines the subgraph shape. A component is ontologically structured into a behavior graph, and the behavior graph editor allows you to edit, change, or extend this graph. On the fly, you can set up test points and inspect behavior and property. Behaviors describe what something does to act upon the world. They're standard across the domains and therefore generically introspectable. For instance, resistance is the same concept in mechanical friction, electronic, hydronics, and air systems. If you click on a behavior, you can open its activation function displaying the physics that defines the behavior. You see a full typeset of physics editor with statistical modeling tools. Quantum Creator provides a whole suite of test and validation tools, including behavior stimulus, sanity checking, and validation graphing. And when a model is complete, Quantum Creator performs a validation pass alerting to any problems in your digital twin. Once you've made an equipment model, you can train it against real-world data, including uploading a picture of a spec sheet. We make it easy to create visual constraints, manage training runs, and create libraries of variants by manufacturer and model. We've built Quantum Creator to enable manufacturers to build libraries of first-class compatible digital twins that are quantum first and enable community sharing. We're really excited to get this into your hands and accelerate the Quantum Alliance.
Today, we've introduced 4 major breakthroughs. A breakthrough platform for generative autonomy with 8 hardware products that each fulfill a role in the overall platform. A revolutionary ecosystem of digital twin applications encompassing 6 software products that span the entire building lifecycle. Quantum, the first digital twin language for composable AI, which includes the AI stack and compute engine that performs inferencing operations on quantum models. And finally, the world's fastest AI language and toolchain, making edge-based AI training and generalized differentiability a reality today. We've pulled back the curtain on the products and technologies that we've been building at PassiveLogic. Now it's your turn. Today, our strategic partners are receiving an early release of some of our products, and in December, you'll be able to engage with Building Studio, Quantum Lens, and Quantum Explorer through your PassiveLogic portfolio account. Sign up to join the waiting list today at PassiveLogic.com. We've built a tremendous amount of technology and many features, and we'll be progressively rolling those out over the coming months. We look forward to engaging more deeply with the community and are excited to see all the new and innovative ways that you all will use these tools. We invite you to start your own projects, and we look forward to hearing your feedback.
Thanks, Jeremy. The community is super important to us, and we will always be committed to providing a free tier for non-commercial, personal, and research use. This has been a super fun event for us, and we thank all who participated today, including Apple, NVIDIA, Brookfield, UDR, Prologis, Tech Systems, Rath Associates, Kajima, and Chris Latner. And we can't wait to show you what comes next.